third webinar in the directed webinar series, Building Resilience Through Data, Governance, and Communication. Today's session is titled Data for Resilience, Building the Directed Data Fabric. Across Europe, organizations involved in climate change adaptation and disaster risk management increasingly rely on data, models, digital services to support their decision-making. However, these resources are often fragmented across institutions, sectors, and geographical boundaries. This webinar explores how interoperable data infrastructure can help address these challenges and support more effective climate change adaptation and disaster risk management. Today, we will be exploring the Directed Project's award-winning open source data fabric and the role it can play in helping organizations make better decisions before, during, and after disasters. From flood resilience to early warning in Emilia-Romagna, to combining climate change adaptation and disaster risk management planning in Denmark's Roskilde Fjord. We will hear how the data fabric is helping connect data, models, and services across traditional organizational boundaries, an approach that has recently earned European recognition through the Direction Awards in 2026. Through today's session, we will hear how the data fabric has been applied in practice through Directed's real-world labs and explore how interoperable data ecosystems can support more effective preparedness, response, and resilience building, and what this could mean for organizations across Europe. You, as the audience, will be able to interact through the session's Q&A function, and we will respond to questions towards the end of the webinar after our panel discussion. Copies of the slides that you will be seeing and further information on important links and our speakers can also be found in the resources section of Zoom. I will talk about this more later. But now I want to thank everyone for joining us today and go on to our first speaker, Paolo Mazzoli from Directed Partner SaferPlaces. Paolo is an environmental engineer with over 15 years of experience in environmental impact assessments, hydrology, hydraulic risk assessments, and climate services. He is a co-founder of SaferPlaces, a global AI-driven flood risk platform, providing intelligence at property level to support communities in developing effective climate resilience and adaptation strategies. Paolo has been closely involved in the development and the application of the Directed Data Fabric and will share his experience illustrated by practical examples of how interoperable data and models and services can support the decision-making across different climate adaptation and disaster risk management domains. Paolo, over to you. I will be sharing my screen. We'll be ready in a second.
Thanks, Mike. Thanks also for the introduction. Good morning, everyone. Mike is saying Paolo Mazzoli. I don't see the screen, Max. Do you see the screen?
I'm sharing the screen. I hope you all can see it.
Okay. Well, for the moment, I don't see the shared screen anyway. We can go. I hope everyone sees the screen, and I will do. I will kindly ask you to change the slide. So, good morning, everyone. And today I will provide you a brief overview of the data fabric, which is one of the main tools developed and directed to tackle the issue of multi-hazard risk assessment, management, and climate change adaptation. Starting from example on how we apply the data fabric in the labs, this living environment in which we developed our novel approach to tackle a multi-hazard. You know that as Max anticipated, territories are exposed to multiple interacting hazards. So decision makers, those we worked with, needed to tools that would really move them from a complex data set and knowledge to something actionable, particularly also during emergency. That's where the data fabric comes into place, providing high resolution hazard modeling together with link to different sources of data, real time sometimes, and the knowledge of the stakeholders embedded inside to create this new interoperable tool to support them both for emergency and long-term planning as well. Next, please. Our fieldwork roots in 4 war labs span across Europe. They face very different climate change, from flooding in Denmark and Rhine to, again, flooding and agricultural risk in the Danube region, and floods again and wildfires here in Emilia-Romagna. So because these hazards are so diverse, we didn't build one rigid platform. We just customized, developed 4 instances of the data fabric, customized to their needs, to the specific needs of each territory. And today I will show you, starting from one example that is from Emilia-Romagna. Next, please, Max. Emilia-Romagna, we have 2 different areas. On the north, Comacchio and Mesola, on the south, Rimini. In the first one, wildfire problem, particularly during summer and the touristic season. On the south, fluvial and coastal flooding. Again, may happen also during summer where it's full of tourists there. So next, please, Max. I would start with a concept. We developed the data fabric with the human-centric operational intelligence approach, putting people like Pietro, who is the officer of the Municipal Civil Protection Agency, or Paolo, who is an officer of the Regional Protection Agency, at the center of this process. They maybe deal and have to collaborate during the same emergency, but from different perspectives. They need to rely on comparable information, but often and frequently they do. Their work is disconnected, at least when it comes to data provision, for example, or model choices. So these 2 different needs shouldn't be disconnected anymore. That's where the data fabric comes into place to support them with a unified interface that provides coherent information from all the available sources and the models to make decisions over comparable, be on the same page, to simplify a bit the concept. Okay, next, please. The data fabric is the tool that we use to try to fill precisely this gap. If you look on the left, we have what's there, what was there before. I mean, the baseline, fragmented tools, every office with its own, let's say, way of working or nuance of tools, separated with quite frequently workflow, and data coming from different sources, not always exchanged smoothly, and also static outputs, frequently pre-done, pre-cooked analysis, also to be done, used during emergency. While on the right, you have what we wanted to do, and I think we achieved with the data fabric. So one single interface that joins and put together all the information, the data, and the models into interoperable pipeline that create new high-resolution dynamic, for example, flood risk or wildfire risk intelligence to be exchanged also in a very interoperable and exchangeable way, and to be used both for planning and real-time operation. Next, please, Max. The hazards, they don't always happen in isolation. Multi-hazard is one of the mantras directed. For example, in Rimini, you can get simultaneously coastal and pluvial extreme events. That's why one of the requirements of data fabric was to be able to deal through the same tool multiple hazards. Next, please. Just a quick snapshot of the data fabric in action in Rimini. So through the same interface, you can get access to the radar map provided by the Regional Environmental Agency. And in terms of minutes, so while the radar is providing you the information, convert these into flooded area on the ground to see where are the critical underpasses, where are the critical roads, where are the critical flooded areas, and decide where to move, for example, the emergency squads, the volunteers. This is the typical example of use of the data fabric, but this should be done easily because they don't have time, because there are few people, they don't necessarily are expert in hydraulic, but still they need to arrive to a result in minutes. That's why the interface of the data fabric has been designed to be as easy as possible for technicians. So through step-by-step guided workflow, just decide the event, click run, decide the model, run, and see the results, like you see here in this slide. Next, please. We should have the video now, Max. No? Can you turn the video on? Working? Because I don't see the screen. Yeah. So from this video, you see that this video shows practically what the fabric can do. Someone can just access, look, for example, what the radar or the ground station data are providing, and then decide which is the kind of event they want to simulate. Then they run it and see immediately what's happening on the ground. Not only what's happening on the ground in terms of flooded area, but also being able to cross-check this information with exposed assets, like flooded buildings, and also through a dashboard, decide the level of exposure, the level of water depth in front of the building, and filter, immediately look at the number of hospitals, the number of schools, the number of critical infrastructures that are at risk. As you can see, this easy way also to isolate and cross-check hazard and damage and the vulnerability. Also, thanks to the layer of vulnerability layer, which put in evidence where, and in the city, in this case, we have the higher concentration of elder people, for example, most vulnerable people. Being able to cross-check and overlay hazard and exposed asset gives a strong boost to the decision you have to take in the field. For example, the priorities, where to put people, where to drive the squads and the volunteers first. Max, can you confirm, please, that the video is over? Because I don't see the share. Yeah, okay. So if the video is over, please go to the next slide, which is on wildfire. I was saying multiple hazards. So directly, it's not limited to flooding, but the concept of the data fabric is that through the same unified interface, you should be able to pilot more hazards. That's precisely what we did. For example, in Emilia-Romagna, we provided also the wildfire module inside the same interface. So we integrated the knowledge of the stakeholder. In this case, we're talking about fire, the field maps, which was something that we had to stress a lot on according to the experience, for example, the firefighters. Then, through the same interface, piloting a completely different model, wildfire propagation model from the Shima Foundation, to get near real time while it's happening the fire spread map. Next, please, Max. So again, everything should be as easy as possible. Just, for example, clicking, selecting the ignition point where the fire starts, selecting the time frame, selecting the wind, which means deciding where the wind is blowing, or picking without doing effort, just choosing to pick from the meteorological forecast, which have been linked really in the background to the data fabric, talking about data interoperability for many different sources. Next, please, Max. And then getting in minutes, while you are there with firefighters, with volunteers, the fire maps of the spreads. Anticipated in forecast of the next 15 hours, for example, or 6 hours, just to decide where to move the volunteers and the firefighters in order to mitigate and contain the effect of the fire. Next, please. Let me jump a bit back to the impact side of the story. This, as a projection, become useful, as I was briefly mentioning before, when you are able to combine them with the exposed assets. I mean, the buildings, the vulnerability, the vulnerable people. So you're able to turn this very solution information into actionable decision and prioritization. This is one of the key points I would like to stress. And this is done, again, inside the unified interface of the data fabric. You don't have to jump back and forth from a GIS system to data fabric. You have all in one system. Next, please, Matt. And we can do more. For the moment, we have seen what happens in diagnosis mode, but we can also work in advance with the data fabric. We can plan to mitigate the results in advance, like putting barriers, putting sandbanks, putting permanent barriers against coastal flooding. Next, please. This is exactly, for example, what the municipality of Rimini did using the very same coastal flooding model from SaferPlaces platform we embedded in the data fabric to decide to build the sea park. The sea park of Rimini is a nice sea promenade, which is not only a piece of landscape architecture, but is also, as you can imagine, an artificial protection against coastal flooding for the hotels, for the houses nearby. This is just an example of using not in emergency, but in planning, as a planning tool. Next, please, Max. So jumping to the lessons. I guess the first lessons we understood from this data fabric was that really we had to move from complex, even complex hazard modelings and data retrieving tools to actionable informations. So systematizing, putting everything into one container, into one tool, gave them the possibility to span from anticipating, forecast, monitoring, short-term, long-term, understanding the effect on the ground and overlaying with the vulnerable, for example, people and the exposed asset. I mean, having all in once the information to decide which was the most appropriate action to put in place. Next, please. And last slide. Again, we are in the last slide of the presentation here. The second lesson I would say we took from Data Fabric is the shift of paradigm that really made possible. But traditionally, if you remember where I started from, traditionally the risk reduction and climate change adaptation usually rely on a set of different tools in different offices, different databases that not always are shared or talk the same language each other. I would say institutionalized workflow, but different, coordinated at best, but still disconnected. Directed, try to put in a single infrastructure all this knowledge and data for disaster risk reduction and to support really from the volunteers to the man in the control room to the municipal office in taking the most appropriate decision either for emergency or planning to support them really with a coherent set of information, scenarios, and model, and they can exchange each other very, very quickly. I guess that's it from my side, Max. That's the end of my presentation. So thanks for your attention.
Thank you so much, Paolo. Those were some really good insights into how the data fabric was developed and what its capabilities are. We've now seen these examples of how the data fabric is put into practice, and we want to explore also how you can build a data fabric for your own stakeholders and for yourselves and your organizations. And to answer that question, we will hear from our colleague Martin at 52 North, who has led the technical development of the directed data fabric and will explain how these capabilities can be achieved. Martin Pontius is a geophysicist by training and works as a senior software engineer at 52 North Spatial Information Research GmbH in Germany, a non-profit company focusing on applied research in the geo-IT domain. And his focus lies on spatiotemporal data science and spatial research data infrastructure, such as the data fabric. In the directed project, Martin closely worked with the software engineers on one side and the end users on the other side for building the data fabric to support climate change adaptation and disaster risk management across Europe. Martin, over to you.
Yeah, thank you very much, Max, and good morning, everybody. So let me share my screen. Okay. Yeah, so in the previous presentation by Paolo, we heard how the data fabric can be used in practice to solve problems in climate change adaptation and disaster risk management. And I would like to talk now about the underlying concepts that we used and the architectural approach. So in the end, I hope with this information, we can help you also to build your infrastructures or to optimize your infrastructures to solve your issues that you're working on. So taking a high-level view on climate change adaptation and disaster risk management, we can see there is a lot of complexity. We have seen before there are different phases. There's the response phase in the immediate occurrence of a disaster event. Then there's the recovery phase. And hopefully in an optimal world, we have the prevention phase also and the preparedness phase so that subsequent events are not that destructive anymore. Then we also have different timescales. So in terms of data, we have real-time or near real-time data. We have short-term forecasts like weather forecasts for the next hours or days. And we also have the decades or century-long climate projections that we also need to understand to prepare effectively. Then we have different spatial scales. We need localized information, but we also need global information on the whole weather system. We have different governance levels or governmental levels. We have national levels, also international corporation, regional and localized governments, which all work differently because they're in different countries, speak different languages. We also have multi-hazard situation with also including compound events. So all this leads not always, but often to silos in practice. So we have fragmented system. There is data, there is models, but they are cannot easily be combined and used together. So in practice, we have several barriers. We have application barriers. We have barriers to our responsibility, communication barriers, and of course also technical barriers that we focus on here today. In terms of data, there is a lot of data out there, but it's often very generic. And needs to be collected from different sources. So it's not easily accessible and not always in the shape that you need it to solve your specific issues of local stakeholders. So you need to collect data from many places to get a complete picture and still post-process the data and put it into the shape that you need it. So summarize that it's a lack of actionable information. So this is really not helping to make timely decisions and to ground your decisions on accurate information. And yeah, on the technical side, there's limited interoperability of data models and the information products that in practice leads to inefficiencies and also delays. So especially in the response phase, delays can be deadly in the end. So it's really important that there is interoperability and efficiency here. How do we try to overcome these barriers? There are mainly two concepts that we follow in the direct project, which are interoperability and co-production. So we've heard from Paolo in his presentation that the tools, the data fabric was developed not only with software engineers and modelers, but also including the stakeholders, and they decide what should be built and how it should be built to ensure that the tools are aligned with the needs and expectations from the end users. Then we also follow, wherever it is possible, open source, open data, and open science principles to enhance the overall accessibility of the data and models. So what we build then is the data fabric. It's a cloud-based federated, not fragmented infrastructure and interoperable system that should make the data exchange and usage seamless for the end user. What are interoperable architectures? What do we mean by that? So on the technical level, there needs to be considered mainly two kinds of interoperability, which are on the one hand, the data and metadata interoperability, which can be achieved by having data metadata standards. And on the second hand, there are interface standards. So not only about how we package the data, but also how we share the data, also in automatic systems. So you can see here in the diagrams on the left-hand side, so we have two architecture approaches. on the left-hand side, we have a non-interoperable architecture, and on the right-hand side, an interoperable architecture. So shown here with the classical client and server approach. So if we don't have interoperability, that means that a client can only communicate with one server because the client doesn't understand how to exchange data with all the other server in the network. And if we have interoperability, if we follow standards, we can magically communicate or span this network and communicate in many different ways to many different servers. We can access weather data from one server. We can access DEMs, digital elevation models, from other servers easily via the same interface with no additional effort in implementing the communication patterns, because they all follow the same standards. So which kind of standards are we using for the data fabric? So for the data standards, we have to differentiate mainly in the spatial domain between raster and vector data. For raster data, we use geotiffs and cloud optimized geotiff and netcdf files. They are all standardized by the OGC, the Open Geospatial Consortium. If you haven't heard about that, the Open Geospatial Consortium is an international standardization organization which follows or mainly develops standards for the spatial domain. For vector data sets, so for point features, polygons, or line features, we mainly use GeoJSON standard, which is standardized by the Internet Engineering Task Force, IETF, and GeoPackage, which also is standardized by the OGC. For the interface standards, we use mainly three standards. The Web Map Service, WMS, which is kind of more traditional standard for the OGC, originated from the early 2000 years, but it's still widely adopted. And if you share your data with the WMS standards, you can make sure most of or all of the tools in the geo domain know how to communicate with that. And then we have also two standards more from the newer OGC API suite of standards, which originated about 10 years ago, which is a more lightweight and modern way how to exchange data. So we have the OGC API features for vector data, and for processing, we have the OGC API processes. And overall, we also follow the FAIR data principles to make the data findable, accessible, interoperable, and reusable. Apart from this, very technical standards, we also want to highlight the semantic interoperability, which is also included in the data fabric. So that means that you can see here on the left-hand side a screenshot from the data fabric. Users can here make a flood modeling, a flood simulation with the SaferPlaces model, and they would like to do, for example, pluvial flood simulation. But for people who develop the model, it's clear what is meant by pluvial flooding. But end users might don't know that, or they have maybe a different perception. So to have a clarity here on the semantics of the key terms, we also included a taxonomy, and users can click on specific terms in the data fabric, and via an API to the connectivity hub, they get the explanation of these terms. So the connectivity hub, which you can see a screenshot on the right-hand side, is developed by one of our project partners, and it integrates many different terms from the climate domain, climate sciences. The core taxonomy is taken from IPCC and the United Nations Office of Disaster Risk Reduction, but it's also extended via harvesting different projects and platforms in addition. Now I would like to show you the overall architecture and core components of the data fabric. So the data fabric is built in a very modular way, and we are using open source components as much as possible. The structure overall runs in a cloud environment, in a Kubernetes cluster. We have three different layers. So we have the user interface layer and the backend layer inside of our managed Kubernetes cluster. And we also connect to external services, which mainly provide data from meteorological agencies. The user interface layer at the top here, you can see, as was mentioned before in Paulo's presentation, we have built in a unified interface, but apps specifically for the rebirth labs that we have in the project, for the Danube region, for the Emilia-Romagna, the Rhine-Erft region in Germany, and the Roskilde Fjord in Denmark. These apps are built with the technology stack of React and Open Pioneer Trails. The Open Pioneer Trails is an open source web framework that makes it easy to build web map-based applications in the web. Then we have the back-end components. We have, starting from the left-hand side, we have data providers. We use GeoServer and PyGeoAPI. PyGeoAPI is a server implementation of the OGC standards, more focusing on the new OGC API suite of standards. GeoServer is a very long and state-of-the-art project in the geo domain. It also includes the classical OGC web services like WMS, but also implements newer standards as well. And these data providers are used to share the data with the users and the tools. The data is ingested with different ingestion processes. They ingest model outputs, which might be created by the modelers and the experts, but they might also come from forecast APIs like the external services from the Danish Meteorological Institute free data server, from Geosphere, which is the weather and geo affiliation in Austria, or from the German weather service ICON EU model. Data from all these kind of places is ingested and collected into this uniform interface. Then we have the models. We have static model outputs, but we also support on-demand modeling configured by the users. And we have a processing API built for that. I will explain some details on the next slide. We have the connectivity hub, as mentioned before, and we also have an authentication and authorization integrated in the data fabric. We use the Keycloak component as an identity provider and the OAuth 2 proxy for the authorization patterns to protect specific data sets, which shouldn't be accessed openly by everybody, but only by specific users. Here I would like to share some details on the on-demand modeling. So typically, models are expert tools. You need a lot of knowledge. You need the software and hardware to run models, but we would like to do it more easily accessible for end users who don't have all these kind of resources and knowledge, as was already shown with the flood model in the previous presentation. So we follow this approach here. So on the right-hand side in the diagram, you see an end user would like to request a new model result, for example, a flood map based on forecast data from one of the weather agencies. Then the user is using the user interface, can click on a button, and then in the background, this will make a call using the standardized interface, in this case, the OGC API processes. This will then go to the PyGeoAPI server component, which understands the request. And so the layer of the management of these kind of processing jobs and the execution is separated. So the PyGeoAPI component will take and understand the request. It has an integrated Kubernetes job manager component, which then is handing over the request to the actual processing component. So we have different models integrated, like SaferPlaces that was mentioned before, and Climada for the risk assessment side, and Room2D is also another flood modeling software. And the Kubernetes cluster then taking over the job. It can handle different kinds of hardware requirements. For example, Room2D needs GPUs, and SaferPlaces Climada run on CPUs. So the Kubernetes layer is then handling all these details in the background via annotations. So this approach, as mentioned, offers the possibility to separate the management, the request, and the execution layer, so we can overcome these technical barriers We can make it easily accessible by end users. We make it interoperable via OGC API processes. And we also use the heavy resources very efficiently. So GPUs don't need to run all the time. It's expensive. It needs a lot of energy. If you only want to do a model calculation 1 hour a day, then you can use the cluster auto-scaling to only run the GPU node for 1 hour, and then in the other 23 hours on a day, the GPUs are not used. Yeah, these are the technical details and architecture. I would like to also talk a bit about the development process, how we work together with the stakeholders to really tailor the data fabric to the actual user needs and make sure that it's really well aligned with the use cases. So at the beginning, we had the initialization phase, first identifying and establishing the stakeholder groups, understanding who are our users, what's their roles, what's their background, what do they want to achieve, what are the specific maybe barriers and limitations they face in their daily life. And then we have also established the task forces inside of the directed project, one task force per real-world lab. And within the task force, we have a representative from all the different work packages. So we have all the expertise that is needed. So we have the modelers, we have software engineers, we have practitioners, we have people who are experts on the communication governance and the knowledge transfer. So we really have all aspects covered here in these task forces. And then after this initialization phase, we have an iterative process. We are defining or have defined requirements as personas and user stories. So who has a requirement, where the person is working at, which organization, and what's the responsibility, and then who wants to achieve what and why with which goal. And these are kind of the guardrails for the developments. These need to be translated then to technical implementation tasks, and then the implementation takes place. And once a new feature is released, it's reviewed by the stakeholders, by the end users. We have different cycles here. We have the continuous feedback and feedback via regular meetings. And we also have larger feedback rounds in stakeholder workshops that were held every couple of months in the different real-world labs. They happen sometimes online, sometimes in person, to really get the intensive feedback and an easier communication. All of this process is grounded in the risk tandem framework within the directed project, and also within the Agile development circle you can see on the right-hand side. Yeah, and finally, I would like to talk about the sustainability of what we have built here. So some key aspects are the modular architecture. So it's really easy to reuse the whole system, or also if you're only interested in parts of it, the data ingestion, specific models, maybe the user interface, all these kind of modular components can be reused and in different systems and environments. They can also be extended by custom models and custom data sets. So there's a seamless integration in the whole infrastructure. We follow open standards to ensure the interoperability of the system. The code is open source. We have a GitHub project for directed, where you can find all the resources. We have the system designed to be operated in a cloud environment, so it's scalable. Yeah, whether you have 5 users or if you want to scale it up to 200 users. So that's possible by having this Kubernetes setup. Then we have a documentation. We have a user manual, which is hosted on Gitbook. And we have training material really focused more on the, not the technical side, but the usage side. We have an e-learning platform on the WeAdapt website with 3 main modules, which explain how the data fabric can be used in practice. And yeah, with that, I finish my presentation, and yeah, thank you very much. Here are some links also to the resources if you're interested. And as Max said at the beginning, they are also linked in the Zoom resource section. And with that, I go back to Max. Thank you.
Martin, thank you so much for this technical deep dive. You saw in Martin's last slides a lot of links to the tools that are integrated in the data fabric. And we keep talking about the resources section in the Zoom interface. If you go all the way to the bottom of your screen on Zoom, you see a menu that's indicated by 3 dots and where it says more. And under that, you will be finding the resources, the slides that we're showing, the links to all our documentation and code and information about our speakers. So please head over there if you want to learn more. And now we will move into the panel discussion section of today's webinar, bringing together our developers and users to reflect on the practical value and the future potential of the directed data fabric. This will be an interactive discussion rather than a formal presentation, allowing us to explore the practical experiences and the lessons learned and the opportunities for a wider uptake of the technology. And for this panel, I would like to start with you, Paolo. I would like to ask you, how can these improved interoperability infrastructures support decision-making before, during, and after disasters? Do you have some real-world examples for us there?
Well, I think that I also gave some examples during my presentation. So thinking about before, no? You remember when I was talking about the Parco del Mare in Rimini, no? This is pretty much an example of acting before things happen. If you have time, like planners usually do have, you can test many different situations and mitigations, like the Parco del Mare, the new reversible promenade. And you can make many what if scenarios, because planners and designers may change the idea along the way for many constraints they have to face. So having the ability to have like a private consultant on your right, which is a data fabric platform that in minutes gives you the results. What happens if I choose this time horizon in climate change? What happens if I change of 1 meter my mitigation measure, and see immediately if this is feasible or not? Gives you clear advantage. And this is all thanks to the high interoperability of modern data which are provided through the data fabric. This is for the first example that came to my mind when it came to before. During, think about the Civil Protection Agency, the emergency, being able to translate in minutes radar meteor, ground station models in flooded areas on the ground in minutes, and see what happens, what is happening, what will happen in the very next few hours. So here interoperability really creates a boost when you have to take a decision during emergency, because you have a clearest picture of what you can expect and how to act. So during probably is the most easy way to explain the advantage of interoperability. After, there are things to do even after emergency, after a flooding, for example, and being able to automatize extraction of hazard overlaid with exposure, overlaid with buildings, with vulnerable people. Also evaluating most damaged assets clearly gives a boost when you have to think about post-recovery intervention. Also, where to prioritize funding. Sometimes, no, without official data or really at hand, but you have to do it right in the hours, right after, in the days right after the emergency. So this is recovery, so to speak, is one of the fields where interoperability is more advantage, maybe.
Yeah, thank you, Paolo. I would like to now welcome our colleague, Dr. Tatiana Ferrari, to the panel. Tatiana is a climate economist and was deeply involved in the co-creation of the data fabric with users in Denmark all around the Roskilde Fjord. And I would like to hear your perspective on how these connected data ecosystems that we've learned about now support climate adaptation planning and resilience building in the region that you worked in.
Hi, thank you, Martin. So I will start just giving like just a situate the Roskilde Fjord for us to understand. So Roskilde Fjord was identified as a risk flood area during the last national flood risk assessment carried for the Danish Coast Authority under the implementation of the EU Floods Directive. And as a result, we have like 5 municipalities around the Roskilde Fjord. And now these 5 municipalities have the legal obligation to prepare a flood risk management plan to addressing the impacts of these cold floods both on people, infrastructures, and economic activities. We have cultural heritage problems and also in the environment. So the work that we're doing in this real world lab is like more like to supporting these municipalities during this planning phase for this adaptation plan. So during the first stage of the co-production process, the stakeholders explained that their main challenge was not the lack of climate information, but it's more like usability problems. So for example, in Denmark, we have the Climate Atlas, which provides us future projections of sea level rises and other climate variables under different SSP scenarios, return periods, and yeah, so on. But however, the stakeholders found this information difficult to translate into practical planning decisions. So they want to understand what a projected water level of, for example, 2 meters or 3 meters would actually mean for their municipalities. So which areas will be flooded, what assets will be affected, and so on. So the data fabric was to develop to bridge this gap, this usability gap for them. So harder than actually is not generating new climate information. Actually, it's connecting existing climate models, hazard and impacted data sets into a common platform for the stakeholders. So so it translated this, for example, climate projections into flood maps and impact assessments that are much easier for planners to interpret and use. And this allows municipalities to explore different flood scenarios and directly visualize their consequence for the planning. And just one more note that I think is important is that the platform does not rely on a single flood model. We integrate 3 different modeling approaches in our case. That is Skalgor, SaferPlaces, and Rin2D, with the idea for the users to compare results across these models. So, you know that every model carries their uncertainties because they are based on different assumptions. So presenting multiple simulations helps municipalities to better understand the range of possible outcomes and higher than relying on single prediction. And this provides a more transparent basis for them to discuss the uncertainties and adaptation plans for the future. So yeah, I overall say that the connected data ecosystem supports like this climate adaptation planning by making existing climate information more accessible, understandable, and actionable for the municipalities.
Yeah, thank you, Tatjana. And you brought up a very important point, I think, due to the modular structure of the data fabric. It's possible that users keep using models that they are familiar with and they plug them into the system. They work with these models, but they also have the opportunity to compare them to other models that are on the market, other models that are available from the research community, and they all come together under one platform, and they get this overview of, as you said, what different assumptions, what do they lead to in the results of the modeling, and they have the opportunity to get a better understanding of the uncertainty that they have to deal with in their planning scenarios. So I think this is a very important point, the modularity of the system and what it enables. I was wondering, Martin, could you reflect a little bit in the development of the data fabric? What were sort of your biggest challenges that you faced in this process? You showed us this agile development circle that I thought looked very elaborate. It was a very long process that involved a lot of people. Could you identify some of the technical, but also some of the organizational challenges that you had to overcome?
Yes, so from the technical side, I would say, so you have talked about how it's really helpful to have different models and compare the models across different platforms and organizations. And from a software developer point of view, I think that was also very challenging because models typically, they are not built for system integration. They are built typically expert tools built by domain experts, not software engineers. So they're really strong on the algorithmic part. They are validated with real-world use cases published in papers. And so this part is really strong, but the integration into IT systems is not the main focus typically. So taking these models, understanding the requirements in terms of software, hardware, and then translating this into a system to make it interoperable, that was really a big step and really challenging. And I think we made a big progress here in the project to make this easier. So the end user, there's a lot of complexity, but the end user doesn't see it in the end. Just using the data fabric user interface, you need to still understand like the kind of configuration and the underlying idea, but maybe just enough to know what amount of rainfall do I need, how long is the event, and then you get a result. So the complexity is hidden for the end user, but for the people who develop it, it's very technically challenging.
Yeah, thank you. This is making me think of this entire developing process, and I was wondering, Paolo and Tatiana, could you reflect back on this process and tell us what was the most unexpected request that you received during this process from your stakeholders that they would like to have integrated into the data fabric? Because it was the stakeholders that were driving much of the development work. Could we start with you, Paolo, please?
Yes. I mean, where to start? I would say that the whole process was a big surprise in the sense that with stakeholders, as a technician, as a modeler, you start with a biased view, so to speak. No, you think in terms of data, resolution, accuracy of the model, equations. Is this representing the physical process better or not? Then when you touch base with the people working on the ground, you see that they pop up with a very clear idea in mind of what matters and what not, which is usually is not matching with your previous idea. Like, for example, the firefighters gave us a very precious hint, expected, that was about concentrating on the fuel map, because if you miss that piece of information, then you can use whatever accurate model you have, and it's not getting it. It's not going to reproduce accurately. No?
Yeah.
Or, for example, colleagues working in emergency in Rimini have also on the capability to link to the radar and get accurate radar data. And this is also a challenge technically in terms of reproducing and making radar maps comparable to the ground data. I mean, it was the process that was surprising, and the fact that you had to sort of drop your, so to speak, technical prejudice on what's important and what's not, and pay attention to and follow as an IT and as a modeler the keystone, the cornerstones, the milestone that they gave you along the way, so to speak.
Yeah. Thank you. Tatiana, how was that with the stakeholders in the Danish municipalities? I know the municipalities, there are a lot of municipalities along the Roskilde Fjord. Did they all have similar demands, or did they face very different challenges and therefore made different requests on what to add to the data fabric?
This is a good question because, well, the process of developing the data fabric was based on then we develop, then we have like feedbacks, like, and change. So I remember that in the beginning, they are more like asking just to this translation of these hazards into the maps. And then we built these scenarios for them. And when you present, they said, no, it's too difficult. We still don't don't understand. So you need to really understand and try to build the problems and try to build this in a very easy way for them, because sometimes what they said to you is not exactly how they want to be looking and using. And every time that you have like these presentations and feedbacks, they also come with a new features that they want to be added to the data fabric. So we need also to understand that you have two different users. You have the municipalities that are more based on planners, and you have also the emergency managed practitioners that need more like real-time forecasts and informations to support operational decisions during the flood events. So for them, they start to ask us to incorporate like some wind forecasts, and we did this through the API with real-time data from DMI incorporated to the data fabric. So instead of just having the possible scenarios, you also have like this forecast integrate in real time, so they can see also the wind that influences a lot on the on a case of storm surge event in the area. And also, recently in Denmark, there is a lot of discussion about groundwater problems, and also there is like a flood that can come from this groundwater. So some municipalities don't face exactly the challenge for storm surge directly, but also from the rivers, streams, and also groundwater. So they start us to incorporate also this other data, and it has been a little bit challenge to cope with all this data with a different kind of load is inside with one platform. But yeah, but we're trying to work with.
Yeah, I see that as a vote of confidence, actually, that the stakeholders approach you with requests for more and more features. Actually is a very positive note. And Martin, maybe as a final little question to you, very, very simple question. What would you advise organizations that have heard you explain the data fabric and what it can do? What would you advise to them? How should they approach setting it up?
Yeah, as shown in the final slide, I would build it in a modular way. Not use one heavy component that should do everything, but keep it modular so you can really exchange components and add components, remove components. If you have a new model and everything is in one block, you cannot easily add it. So keep it modular, and then use standards wherever possible. And open source components, it's not always possible in terms of model license. So there need to be the flexibility to include also closed source software, but as much as possible, use open source. And we talked now a lot also about these requirements. It's really complex to understand these diverse requirements on having this kind of continuous and iterative process, talk to the users. So it's really important that in the end, what you build is what they need, and not something that looks nice, but is doing something completely different.
Very good advice. Thank you, Martin. Today's webinar, I think, has highlighted very well the importance of connecting data, models, and services to support more effective climate adaptation and disaster risk management in regions in Europe. And we've heard how the data fabric is helping organizations overcome fragmentation and improve collaboration and strengthen the resilience across different regions, across different sectors, between disaster risk managers and planners. And the fact that the data fabric was recognized through the Direction Award 2026 also demonstrates the growing importance of these interoperable digital infrastructures in supporting our future disaster resilience and emergency capabilities in Europe. If you are interested now in the open source nature of the data fabric or wish to build one of your own, please contact us and check out our resources on GitHub and Gitbook. And now I would like to thank all of you, all the speakers, the participants for sharing their experience and insights today. And thank you all for joining us from across Europe and beyond. And for more information about the Directed project itself, for recordings of previous webinars and further resources, please visit our website at directedproject in one word .eu. And let me announce our next webinar in the Directed webinar series, From Models to Action, Risk Assessment and Forecasting Tools, Opportunities for New Users. This will be held on Friday, the 24th of July at 11 a.m. again, Central European time. And now finally, I get to thank Tracy Irvine, who leads the development and the production of the Directed webinar series. And once again,